Hello, protocols, packets, and programs. Every week, we bring you interviews and news on application security. We go beyond top 10 lists and CVEs with fancy names to find interesting angles and insights. So whether your AppSec knowledge is 0 days or in its early days, join us for another dive into DevOps and security. Which means this week we talk with William Morgan from Buoyant about bringing strong identity and mutual authentication to Kubernetes and service mesh. And service things that are put together. In the news segment, SSRF leads to admin account takeover. A Ruby Markdown extension leads to command injection. Salsa dances with Go, problems with pipes, and more. Check out the show notes and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
SOS.io makes security tools for everyone. SOS's flat rate pricing means you can set up SCA and DAST tools for your whole team. No seat counts, no scan limits, and you never have to talk to a salesperson. SOS integrates with all common CI/CD platforms and supports most popular package managers. And thanks to SOS's open source vulnerability scanner, license management suite, and SBOM generation capability, you can get back to what you really want to be doing, coding in no time. Visit securityweekly.com/SOS.
This is episode 192, recorded April 11th, 2022. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
I am here in at least physically and hopefully mentally, a happy Monday.
Happy Monday. And I was thinking over that break that the collective noun for services might be a mess of services rather than a mesh of services, but we'll see. While we're thinking about that, what other collective nouns we can have in application security, take a moment to save $100 on your RSA Conference 2022 full conference pass. RSA will be live in San Francisco, June 6th through 9th. Security Weekly will be there in full force, delivering real-time live coverage and interviewing some of the event's top speakers and sponsors. Register with our discount code by visiting securityweekly.com/RSAC 2022 and using the code 52UCyber. See you there. Don't miss any of our favorite Security Weekly content as well as yours. Visit securityweekly.com/subscribe to subscribe on any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, Discord server, to chat with us right now and follow us on social media and our other streaming platforms. Which brings us to the important part, which is William Morgan, who's the CEO and co-founder of Buoyant, as well as the creator of Linkerd, the pioneer of the service mesh category. He was previously an infrastructure engineer at Twitter, where he ran several teams building the product-facing backend infrastructure. He has worked at PowerSet, Microsoft, Adapt TV, and MITRE Corp, and has been contributing to open source for over 20 years. Hello, William, and thank you for joining us.
Hello, glad to be here.
We're glad to have you. And as I'm slowly, apparently stumbling all over my words today, I was at least getting names right because identity is important. And identity, I think, is the theme of the day here to talk about Kubernetes, service meshes, and bringing strong authentication to that whole mess, if you will. So maybe one of the things we should just kick things off is sort of why is identity important? And especially, why have you chosen to invest so much time, effort, and on something like a Linkerd or solving this problem of workload identity within Kubernetes?
Yeah, well, that's a great introduction. So thank you. So most of what I've been up to for the past, I guess many years at this point, is in this very specific realm of Kubernetes and kind of the networking that happens. And so as you as an organization adopt this very particular type of platform, you actually there's kind of two things that happen. One is a lot of stuff that was relevant to you in the past is no longer quite as relevant, and that's kind of the sad part. And then the happy part is there's new things you can do that actually become a lot easier in Kubernetes. And so the thing that we're very focused on with Linkerd, which is our service mesh, and there's probably like a 45-minute long conversation we could have about what is a service mesh and what does it mean. which maybe we'll save for another time. But a lot of what we're focused on with Linkerd is how do we provide people with security, especially network security, out of the box when they adopt Kubernetes, and how do we do it in a way that is in line with kind of the modern ideas of network security, which are things like zero trust, and workload identity as opposed to network identity and things like that. So we're able to take advantage of a lot of the primitives that Kubernetes provides for us to give you some very strong guarantees about the network communication in between your pods, both around encryption and transit and things like that, but also around the identity and validating identity and all the policy, and kind of authorization policy built on top of that, from being able to build that on top of this notion of workload identity as opposed to your IP address.
Yeah, and if we could spend 45 minutes defining service meshes, we could probably spend twice as long trying to define zero trust. So instead of, and I don't think we're here just to navel gaze about definitions, it's more about what you were hitting on right there, which is from the DevOps perspective, what problem are you solving for me? And it sounds like you're solving this identity problem in a way that's making things easier to implement, easier to adopt, because mutual TLS layers, those have been around for decades, right? But it sounds like Linkerd is bringing an abstraction that makes this a lot easier. And so perhaps tell us what does make this easier, because one of the things that probably most either security professionals, even and DevOps side of things, will be like, I got to start handling certs, and I need PKI, that sounds kind of gnarly. It's prone to a lot of errors. What have you abstracted away to make this a problem that's not going to make my eyes bleed?
Yeah, no, that's exactly right. So TLS, it's great in a lot of ways, terrible in a lot of ways, it's great in a lot of ways. One of the ways that it's terrible is that it becomes very, very complicated, very rapidly. So, the idea of having a TLS connection between two TCP endpoints, seems very straightforward and great, and provides you guarantees around integrity and confidentiality and authenticity. But then you get into the cert management problem, or the PKI problem, and then it gets very, very complicated. So what we can do is, by virtue of the fact that we are in Kubernetes and that we can be very consistent in our application of TLS, we can actually do a lot of that for you. We can probably do about 95% of it for you. So the way that a service mesh works is it does this very horrible thing. Well, it sounds horrible in the beginning, then you grow to love it. There's this very horrible thing, which is it adds a little proxy. We call it a sidecar proxy next to every application component, and it does it transparently, so the application doesn't know about it. And that means when A is talking to B within the cluster, it's actually going through two proxies, right? It's going on one side, from the client side to the server side. And that gives us a lot of the ability to introduce a lot of features. And one of those, that gets a lot of attention is TLS. And actually, it's mutual TLS. We're going to authenticate not just the server side, but also the client side. But because we are the ones that are inserting those proxies, and because we control where those proxies are getting their certificates from, we can actually do a lot of this for you. So we can issue the certificates to the proxies every 24 hours and have them expire and rotate without you having to do any work. We can have the identity be built on these, kind of Kubernetes, what Kubernetes uses something called a service account, which is basically your kind of like identity, at least as far as permissions go. So we can build the certificates off of that, and we can basically do that all transparently for you. In fact, if you install Linkerd, which I should say is open source, 100% open source, and it's a Cloud Native Computing Foundation project. So, you can install it not having to pay anyone the big bucks. But the moment you install it, all communication between meshed pods has mutual TLS applied automatically. In fact, we don't even really let you turn it off at this point anymore. And it's all possible, of course, due to the fact that we can leverage a lot of Kubernetes things, but also we have a consistent environment, right? We can do this all for you everywhere in your cluster.
Yeah, that consistency has to be something that makes this so much easier, because when we talk, we've alluded to zero trust already, and one of the premises is that your security boundaries are changing. They're different. We're no longer just trusting the IP address. We're not just trusting, you came from this area of the network, therefore your traffic's probably good, or this other area, and we're going to reject it. So I'm curious, as you see, as you've embraced Kubernetes in this manner, and as you've seen or encouraged organizations to adopt Kubernetes as this alternate abstraction layer, a way to deploy their services, have a mesh of them, if you will. How do those security boundaries change? And what are the ways that perhaps Kubernetes makes this, does it make it easier? Does it make it harder to reason through some of these aspects of the mutual TLS, or understanding this is where our identity layer, authentication layer is, but also here's where our authorization layer is as well?
Yeah. So there's a lot to unpack there, and I'll say one of the very early, we actually didn't expect that this was the kind of killer feature of Linkerd. When we first released Linkerd, we were really thinking about some of the reliability features. We have all this logic around request retries and load balancing, and and latency aware request balancing, and a lot of stuff to kind of handle partial failures. But one of our very first experiences was there was a company that adopted, a very large company that said, "Hey, we're using Linkerd, and we're using it to add mutual TLS everywhere." And we said, "Well, okay, great, but why?" And they said, "Well, we have 500 different application engineering teams, and our choices are either we go to each of them and we say, 'Hey, can you please implement it this way?' and here's the parameters you have to follow, and then we'd have to fight with the product manager and get it inserted in their roadmap, which already is like overflowing, or instead of having those 500 conversations, we can just add Linkerd and we can solve it." So that was our first inclination that what we were solving was, we weren't really providing anything new. Mutual TLS had been around forever, but what we were doing was giving the platform team the ability to own that feature set without having to depend on the application teams to deliver. So that was our first inclination, that kind of there's like a social value to this approach as opposed to just a purely technical value.
And
now
part of that social. Yeah.
Well, I was going to say, you talked about zero trust and this notion of kind of where's your enforcement boundary. That's one of the things that's really nice about the sidecar model in Kubernetes is we can add it, like I said, we're adding it next to every application component. In Kubernetes terms, that's a pod, and that's kind of like the atomic unit. So if your application, comprises different services, and those services, you run multiple replicas of them for, whatever, for either HA reasons or just for load reasons, we'll add a proxy into every instance of one of those replicas. And that's where the enforcement now happens. So each of those pods independently is doing its own mutual TLS, it's doing its own policy. And so your enforcement point has, gets shrunk down from the cluster and the firewall, which, you may still have a firewall in place, but now every pod is doing its own validation, it's doing its own authorization, its own authentication. And that's a big part of the zero trust philosophy is you shrink those boundaries down. So you don't even trust them, even the network within the pod, you don't trust it.
Yeah, and that's where, and I was going to take that aspect of your, putting this into the sidecar. There's also an element there of that social contract with your platform team, with your DevOps team, and that you were also, I think, touching on a bit because you were describing looking at, handling error conditions well, handling restarts, handling latency, paying attention to performance, things that, modern, the titles like SREs care about, things like that all have, consequences for that availability in the CIA triad. So I want to shift here a little bit, just get into some of the background of Linkerd and what your path was to get here. There you have a blog post that is pretty interesting about the difference between, or the choice and philosophy between Linkerd, Envoy, and Linkerd is very much focused on being small, low impact. So tell us a little bit about why that is, and especially why, not that it's better, worse than Envoy, but why what the philosophy was that puts you on this path.
Yeah. So I'll start with a little bit of history, which is, the way we got into Linkerd was both, myself and my co-founder, Oliver Gould, who is, the actual person behind Linkerd. I'm just like the beautiful / hideous face of the project, but he's the one who's writing the code. But the two of us were engineers at Twitter at a time when Twitter was going through this big infrastructure transformation, starting in 2010 when I joined. where we had this monolithic Ruby on Rails application. And then by the time I left in 2014, or Oliver left in 2015, it had broken down into microservices, and it was running in an orchestrated environment, and it was using like isolation, and kind of like this very modern kind of shift happened. And when we left, we decided to take this library at Twitter, this open source library that was powering a lot of the service to service communication, and it was so instrumental to this transformation and making that work for Twitter. We said, hey, the rest of the world is going to need this. And that was really kind of the original idea. It was like, well, we have this library, but no one's going to use the library. Let's turn it to a proxy so that anyone can use it, right? As long as you're speaking kind of standard TCP protocols, you can stick this proxy next to it and you'll get the operational benefits. And that was kind of like the first step, there. And that original proxy was actually this very large, it was based on the JVM. It was written in Scala. It was kind of heavyweight, right? And the JVM is very good at scaling up, but it's not very good at scaling down. So when people started running this in Kubernetes, they were like, well, it's great and all, but gosh, it's 150 megs of memory, and my application instance is like 50 megs. So that's not. You're telling me this is this like translation, this like transparent layer, but it's like costing. It takes 3 times the resource cost. So we actually had to take a step back, and we said, okay, the model that really works, if you care about zero trust, if you care about workload identity, if you care about all this stuff, the model that really works is the sidecar model. But that's only kind of feasible if those sidecars are really, really small, right? And really, really fast, right? Because we're adding proxies everywhere, so that adds latency, adds CPU consumption, adds memory. So we took a step back and we started rewriting that proxy in a language called Rust. And this was circa 2018, so Rust was pretty early at that point, and a lot of what we had to do that early on was build up some of the kind of core networking ecosystem. There weren't really libraries to do a lot of things we needed to do with HTTP or with TLS or whatever.
Okay.
But the goal was, and this is kind of the philosophy, we needed to have a sidecar proxy that was really, really small, really, really fast, and also that didn't become annoying at scale to operate. And so we did look around. There were other proxies. Envoy was a very popular one at the time, especially in the cloud native space. But it was a general purpose proxy, and it was designed to handle a lot of different situations. A sense was at scale that was going to be kind of an operational burden. And so, we went down the path of what we call this micro proxy. And that's kind of the modern implementation of Linkerd. And there's a proxy, but it's not general purpose. It's not designed to be even really a user-facing detail. It's designed to just do the work and get out of the way. And you kind of, as an operator, you're interacting with, not with the proxy, but you're interacting with the control plane that kind of gives you the ability to manage those proxies en masse.
Yeah, I'd like to hear you talk a little more about scalability. It's running Kubernetes itself can be an armful. Running these things at large scale, 100 plus hosts gets interesting. I'd love to hear you talk more about what are those challenges that you've seen in either yourself or some of the other proxies out there, and the pluses and minuses between you guys versus them. So I'm not looking for them bad, you good, but it's interesting to hear a little bit about once you start running, I don't know, probably 1,000 Envoy proxies. What does that, why do people start pulling their hair out?
Yeah, well, them bad, we good. I mean, I think that's a pretty good summary. So we can just move on to the next question.
Okay.
No. So, like any engineering decision, this is there's a lot of nuances in this trade-off. The way that the service mesh works with these proxies is very specific behavior, right? It is every proxy is standing in front of one application instance. So, which is very different from what you would do with a proxy sitting at the ingress to your cluster, right? Or like some kind of central bank of proxies. In the sidecar model, typically your traffic requirements are not actually that high. We're talking about the traffic to a single application, usually the application itself, or to a single instance of an application. So usually that instance is kind of bottlenecked, in terms of its own business logic, whatever it's doing. So the requirements were really specific, and a little different from general purpose. And the other kind of aspect there was the operational aspect. That you kind of alluded to the fact that Kubernetes is a lot to take on, and it is, right? You've got it's got it's a great model, and like it's designed really well, and it's composable, and there's lots of different pieces, but the pieces kind of make sense together. But it's a lot to take in, especially for the operations or the platform folks who have to learn this new surface area. We really didn't want it to be, well, okay, now you add a service mesh, and by the way, that doubles the amount of things that you have to worry about, or the amount of things you have to tune, or whatever. So we really wanted to be as focused as possible on the very specific problem of being a sidecar proxy for Kubernetes, get that really solved. And then from there, of course, we have to, we've got to solve other problems, right? It turns out the entire world is not entirely running on Kubernetes, and probably there's large portions of it that never will be. So the same things that we do with Linkerd today in Kubernetes, the next step for us is expanding that outside of the cluster boundary. And that's where things get interesting. We think about, what does it mean? What does workload identity mean? Right? We have an answer for that in Kubernetes, but once you're outside the cluster, that answer, the framework is no longer there. So that's kind of the next set of challenges.
Maybe along those lines, I'm curious too. So there's also the angle of, should I adopt Kubernetes? And help us think through that, or frame for our listeners what some of those decisions, deciding points, criteria might be to say, well, I would love this idea of workload identity and mutual TLS with short-lived certificates. That sounds great on a security threat modeling type of checklist, or when we talk about how we're reducing risk. But is just getting Kubernetes itself, is that also a security mechanism, security tooling, or is that more of just, this is the operational gotchas that you're going to bring on, that you're trading off consistency perhaps with different types of headaches as it's scaling out? So the short version of that question is, help our listeners who might be considering that they would want to take advantage of something like Linkerd. What are some of the gotchas or the reasons to adopt Kubernetes that aren't directly part of a security decision?
Yeah, that's a great question. And I would not consider Kubernetes to be a security tool. It's an operational tool. It's a platform. Kelsey Hightower had a very famous quote, which I think hit it right on. It's a platform for building platforms. So I would not adopt Kubernetes for security reasons. But if you are adopting Kubernetes, there's a lot of nice things that are security related that you get, Linkerd being one of them. Of course, security is like, a very large area. And just because you've locked down the communication between pods on your cluster using service mesh, fancy MPLS, doesn't mean that there aren't like 100 other things you have to worry about when it comes to securing your cluster. But, if someone were to ask me, like, should I adopt Kubernetes? Gosh, that's a really context sensitive answer. I will say, I think Kubernetes is very well designed. I think it's a great platform for building kind of what I would consider to be the modern type of application, which is you can scale things up and scale things down without having to do a lot of work. You can treat your machine, whether VM or physical, you can treat your machine pool as kind of this like fungible set of resources. And you can adopt a model that gives you some really nice operational benefits. But there's a big buy-in to get there, right? Like it's not like you ease your way on. The moment you have your first cluster, it's like, oh crap, there's a lot of stuff that I have to worry about now. So it really depends on, about 100 other aspects of what's important to you as an organization and where are you going? This is an investment you're going to make. Is this investment going to pay off in 5 years? Well, it kind of depends. Where are you going to be in 5 years? Are you launching like 500 new applications? Okay, maybe thinking about a platform is a good idea. Are you going to be basically doing the same thing and just more so? Well, if you've got something that's working, why screw it up? So very context sensitive.
Yes. Well, yes. Why solve for a scale problem that only, top, 3 or 4 companies with billions of customers and billions of users have? Choose your weapons wisely as you approach these problems. In the spirit of engineering decisions, thought process, I did want to go back to the choice of Rust, because that was now you were talking about where are you going to be in 5 years. Rust was you started around 2018, so that was 4 years ago. but you chose to go into it when it was a really, call it a bare networking ecosystem for a lot of your the support you needed. So maybe a two-part question, since I like asking multi-part questions. Would you have made the same choice today, looking at the ecosystem, or would you look to a different language for that matter? And then the second part of that would be, thinking about Rust, what were some of the things that you would encourage people to also consider? They're maybe adopting Kubernetes, but maybe also instead they want to just adopt Rust. Any, sharp edges or things to think about as it's now maybe a bit more robust?
Yeah. So, first I'll caveat this by saying I personally have never written a line of Rust in my life. And, I pay people to do that.
I asked the question.
I only feel the pain, kind of like, one degree removed at best. But I'll say from the Linkerd perspective, it was a big gamble at the time, hopping on the Rust bandwagon. But yeah, 100%, I would do that again. It worked out so nicely. It paid off big time, because what we get out of that is, we get a couple nice things. Number one, of course, we get the ability to write code that runs at, that compiles down to binaries and that runs as fast as the computer can possibly run, and there's no managed environment, or there's no garbage collector or whatever, kind of the bane of network programs. There's nothing that's cropping up and like hurting your tail latency, right? So we get that. That we could have gotten with C++, or with C. On top of that, we get some really nice security guarantees. The kind of the one of the big goals of Rust was to not allow you to write code that was vulnerable to things like buffer overflow exploits, or the variety of other CVEs that you see in kind of C++ code. Right. And so we get to sidestep a whole class of issues there. And that was really important, actually, even in, when we were first planning this out and thinking about how painful it might be to be on Rust. It's really important to do that, because the proxies, what we call the data plane of the service mesh, that's what actually handles application code, right? And so if our users are, doing stuff with personal, information or health information or financial transactions or, anything sensitive, which they do all the time, that stuff, it really matters. It really matters that data plane is just solid and you don't have to worry about it, and you don't have CVEs cropping up left and right because, it turns out a human being can't actually program C++ code safely, right? So that was a big motivation. And then kind of the third motivation, which I didn't quite expect, but which has been awesome, or the third payoff has been, I would say, if you look at the entire ecosystem today, everywhere of software, network programming software all over the world, I think the most advanced and most state-of-the-art stuff is all happening in the Rust asynchronous networking ecosystem today. And it's funded by all sorts of interesting companies, and that's where it's all happening. So right now, we paid the price to be on the train, but this train is going to awesome places, and we're just kind of floating on. I guess trains don't float. We're just along. Not along for the ride. We're being propelled rapidly into the future. By virtue of the fact that there's all this investment in these low-level libraries that Linkerd depends on.
Yeah, we're working on the mega metaphor for that to get that up properly. But it's great to see that type of investment does pay off over time, rather than this was the hobby language, or this was the obscure non-standard choice that becomes also a barrier to entry for collaboration, communication. So maybe tell us a little bit too. This is Linkerd is part of the CNCF. So how has some aspects of the community embraced it, or the community, or what are some of the ways of that social aspect, if you will, of just bringing people together to adopt, improve, give feedback on Linkerd?
Yeah, great question. So as you say, Linkerd is part of the CNCF, Cloud Native Computing Foundation. It's the only graduated service mesh. So it's kind of like the highest tier of in their maturity hierarchy in the CNCF. And it, by virtue of that, as part of that, I'll say Linkerd is 100% open source. We don't do feature withholding. We don't hide stuff. We invest wholeheartedly in the project. There's open governance. There's a steering committee. There's kind of all the trappings of making this, and we wanted to, from the very beginning, make this a real first-class open source project. Now, in terms of barriers to entry, of course, we're as welcoming as we can. The control plane is written in Go. The data plane is written in Rust. The Rust part is hard. It's hard to contribute to the proxy because it's not just like Rust, which is already difficult. There's, all those memory safety guarantees actually mean the compiler is very strict with you. And you have to like learn how to live with this, this very strict entity in your system. But Linkerd is like advanced Rust. It's like asynchronous, super high performance networking Rust. So it's very difficult to get involved with the proxy. We're as welcoming as we can, and everything's open source, and we're trying to help you. But I will say there has been a barrier to entry getting into the proxy, especially. Control plane is a little easier because Go is a lot more forgiving. But yeah, we try and make it, of course, we want to be as welcoming and as open about it as possible. So we do our best to do that and have a supportive community.
Yeah. And I think, too, what's neat is the, poking around the GitHub repo for Linkerd. You've also got some security testing that was done. I think the most recent one was in 2019, but it's neat.
Oh, yeah. We got a new one that we're about to release. Yeah. We're like a week away from releasing that. Yeah.
Almost there. Oh, I stepped on the big announcement. I guess maybe we won't. Anything you want to tease about that, or anything we should be on the lookout for?
Everything's fine. No,
that sounds believable. Yeah.
Yeah, don't worry. I think it was about as good as it can be. So, there were a bunch of kind of minor issues that were uncovered, which is great. And some of it was stuff that was kind of on our radar. Some of it was stuff we're like, oh yeah, we should do this. There was nothing really critical that was uncovered. And then there's kind of like a roadmap that is easy to see based on, kind of the questions and some of the results. So we got value out of it for sure. And, like everything else with this project, we're going to publish it as is. And, you are welcome to read through it and form your own opinion.
Yeah, and I think too, I wanted to highlight it as well for listeners, because even if you're not adopting Linkerd, just reading the 2019 version as well as the new version that's coming out, it's just a great exercise in looking at a threat modeling process. How do penetration testers, how do security testers think about a honestly complex system like Linkerd, and some of the security boundaries that it has, some of the security assumptions. And you did make this point too, William, that humans are writing code in addition to C++. I've done plenty of C++ mistakes myself in the past, but that's not to say that Rust or Go or any other language for that matter is going to be immune from humans writing it. So it's to be expected that their mistakes will happen, and it's great to see this transparency and embracing community to basically say, here's what we're looking at. And I think there's a subtext there to say, come find more. We are open source. We are, we are welcoming this type of analysis.
That's right. There's a security kind of like reporting process. We publish everything online. We want to make this like Linkerd is a critical security tool for a lot of organizations that are doing very sensitive things with it. So we have to be as open and as transparent about it as possible.
And I think one thing I do want to thank you for, within all of the Kubernetes naming conventions and all the different types of commands and controls that can come around there, I do want to thank you for making Linkerd one of the easiest, non-controversial service names to pronounce. So that's a good one.
Oh my gosh, what a terrible idea to call this thing Linkerd. We have to, like, if you have to have a FAQ entry that's like an FAQ entry that's like, how do I pronounce this project? Then, it's a sign that you probably picked a bad name.
Things are going to be rough, but we would want to say things. What are as we're running to the end of our segment here, but I'd love to hear about maybe a call to action or a call to attention. We've got a security report coming up that we can check out in a week or so. What else can people do to participate within this project or CNCF in general, or something that you'd really love them to adopt related to Kubernetes or Linkerd for that matter?
Yeah, so definitely, start with the website, linkerd.io. It's LINKERD, letter D.io. It's like a demon for linkers. It made sense at the time. So definitely check that out. And then I also wrote, if you're interested and you're still kind of coming up to terms with Kubernetes and MTLS, I wrote a long article about, what is MTLS and why does it make sense on Kubernetes and what does the service mesh do and all that stuff. So if you just search for like Kubernetes MTLS, you'll probably find it. Search for my name maybe. So those are two concrete things, and we have a very welcoming community, mostly in the Slack, which you'll have a point or two from the website. So give it a try, hop in. If you get stuck on anything, just ask for help. We'll get you sorted out.
That's awesome. Thank you. Yeah, and do encourage everyone, check out linkerd.io. Just Google up William Morgan and TLS, and you'll definitely find some really good, well-written blog posts just around the Linkerd in general, Linkerd specifically, but also TLS. A lot of these, why do we need mutual TLS and authentication? So I want to highlight those and just say thanks once again, William, for joining us.
Yeah, thanks for having me.
I want to say thank you to John and thank you to all of our listeners. With that, we're going to take a quick break and return with news of the week.